We're now going to take a look at the third core topic of the Information Processes and Technology syllabus, communication systems. This unit overview will once again be presented in a mind map format. The first area we're going to look at is characteristics of communication systems. First thing we look at is the client-server model and the fact that certain computers or certain systems on the network act as a server which provide resources to other computers on the network. So servers can provide internet access through a web server. They can provide access to email, a mail server, access to files, a file server, and so on. Okay, so these server computers are obviously connected to the network, and all other systems on the network can access these resources on the server. We look at how users can send and receive data on a network, okay, and as well as the communication systems framework. Now, obviously this comes with a diagram, and that diagram is not included in this mind map, but you'll see it in another video. And understanding that framework is paramount. It's actually in the actual syllabus itself. Remember that it has three tiers in that actual diagram: the application level, the communication control and addressing level, and the transmission level, all with associated protocols and different sending and receiving occurring at each level. We also look at functions performed within these systems, such as relating to the generation of a message, how it gets organized into packets before sending, starting the signal and then sending the signal through transmission, synchronizing the exchange between sender and receiver, how it is addressed and routed to a specific location, how errors are detected and corrected, and security methods for ensuring that the transmission cannot be intercepted by anyone else. The next area we'll look at is the information process of transmitting and receiving in relation to communication systems. So here we talk about a whole variety of areas, okay, going through it there. To start off with, transmission media refers to wired and wireless forms of transmission. Our wired forms are optical fiber, which is the best and slowly becoming the standard for everyone, okay, coaxial cabling and twisted pair cabling. And then we also have our wireless methods of radio, microwave, infrared, and satellite. We next look at the communication protocols, and this links into our framework once again. So at the application level, we have HTTP, SMTP, and SSL, okay, which are all used at our application level there. HTTP for websites, SMTP for email, and SSL for applying to security level. And if it's applied to HTTP, it becomes HTTPS. On the control level, we have TCP and IP. So TCP, which is used for ensuring that a message gets to a location, okay, correctly, okay, and IP, which is the addressing protocol, okay, which tells the pathway to a specific device on a network, and you'll see it as a long code split up with decimal points, okay, and they're often used in conjunction together to ensure that it is addressed correctly and that we actually know that it got to its destination correctly. And then finally is our transmission level protocols of Ethernet and token ring. Okay, we look at the difference between intranets, and extranets, and intranet being a private internet, okay, where it's kind of used within an organization, and an extranet where basically we can have some people outside of the organization, maybe customers or clients, who can also access the intranet, making it an extranet. An NOS is a network operating system, which is necessary for running a network. And then we go over certain types of network hardware, such as hubs, switches, and routers, which are all very similar in that they connect networks together, but they all have different degrees of smartness. Whereas hubs simply connects computers together and all the computers are relayed the same data. A switch sends data to specific nodes on a network, and a router is able to send data to specific nodes on other networks through methods such as the internet. We have a modem for modulating and demodulating an analog signal into a digital signal and vice versa for when using the phone lines for using the internet. Bridges and gateways, which are used for connecting networks together. A bridge connects networks using the same protocol, and a gateway connects networks that are using different protocols. We have NICs, which are built into computers, which is a network interface card, and they allow us to connect to networks either through an Ethernet cable or through wireless means. A WAP, which is a wireless access point, okay, which is often seen in McDonald's, which allows us to connect to a wireless network, and then Bluetooth, used for Bluetooth technologies, where we pair our devices. And finally is our network topologies. bus where there is one large cable that all the other nodes are connecting to with cables as well. That large cable is known as the bus line and is the backbone of the network. A ring topology where all the computers are chained together in a ring format. Okay, it is the easiest to set up of all the networks, but also the most unreliable. And a star topology where basically we have our server at the center of the network and all devices are independently connected together to that centralized location. We then have two other forms, which are the hybrid, in which we can see multiple topologies being used in the one location. Okay, so it has a little bit of ring and a little bit of star. Okay, and that makes it a hybrid topology because more than one topology is being used. And now we also have the wireless topology, where there is no cabling, simply a router is connecting all the devices together. Okay. Moving on, we have examples of communication systems. And from here, we have messaging systems, teleconferencing systems, as well as other technology. These messaging systems, examples include email, voicemail, and VoIP, which is voice over internet protocol, okay, allowing our voice to be digitized and sent in the form of an email. Okay, other technology includes e-commerce, okay, which allows us to do buying and selling online. FPOS, which allows for a terminal to be placed in any business, and when we purchase a product from that business, it directly deducts the funds straight from our bank. Okay, and electronic banking, using the internet to manage our bank accounts and transfer funds. The next area we'll look at is managing communication systems. And in the area here, we have network administration tasks. So really, for a communication system, there's a lot going on in the setup and maintenance of that system. For example, adding and removing users, adjusting users to printers, okay, giving users accessing rights. Can they just view a certain file or can they actually edit the file? Installation of software, okay, allowing them to do the specific tasks on the network, okay, doing a client installation or pushing things out through networks, assignment of protocols, log on and log off procedures, and other network-based applications. Okay, other information processing and communication systems include collecting, processing, and displaying. For collecting, okay, when we talk into a phone, it is collecting data. And when we enter in our PIN as well as the amount of funds we need to access on an FPOS terminal, when we're pressing the buttons, that also is collecting. Okay, for processing, we are encoding and decoding quite a lot in communication systems, and it happens a lot behind the scenes. So there's a high amount of processing going on. When data is put into packets, as well as when it is routed and sent to a specific address, that's all processing as well. When we apply security methods of encryption, okay, and then decryption when it's received from our receiver, so the actual message can be unscrambled, so it is readable to its destination. That is a process, and as well as our error checking methods. And the three type of error checking methods we look at in the IPT syllabus are a parity check, when things are given an even or odd parity based on the amount of ones, and the parity bit maintains that parity. A checksum, when basically all the actual digits are turned into a decimal value, added together, and then turned back into a binary digit, and that becomes its remainder, becomes our checksum. And CRC, when all the binary bits are crunched together and turned into one large number, divided by a polynomial generator, and its remainder is sent as the CRC, which is checked at the destination to see if it's correct. And then the final area, the other information processed we look at is displaying. And the examples here are exactly the same as collecting because it's the end result of the person using that device. So on the phone or voicemail, it's the speaker now that's the display device, okay? And that's actually allowing you to hear what was said, okay? So you're actually hearing back. It's being displayed, the sound. Okay, on an FPOS terminal or electronic banking, the screen says what's going on. It's being displayed there. So those devices are both collecting devices as well as displaying devices. Okay, and then the final area we look at are issues related to communication systems. Okay, so current and emerging trends, and then specifically the issues of security, globalization, changing nature of work, interpersonal relationships, okay, and how they're changing from face-to-face to now a lot of social media and how we communicate a lot online. E-crime in the forms of hacking and phishing, okay, where people are stealing other people's accounts and doing fraud. And then the new case of virtual communities, online gaming, the way we know people through these virtual communities and what's going on. So And with our current and emerging trends, okay, we have blogs, okay, which allow, is like Facebook, where we're posting messages underneath each other and they're all getting stacked underneath. Wikis like Wikipedia, where anyone can contribute to an online site and update its information. RSS feeds, where we can centralize what's going on multiple websites and we get sent updates every time there's a new story for us to view. Okay, podcasts, which allow people to record their voice and usually have images as the background, okay, and post them online, and people can download the podcast and listen to them with their headsets. Online radio, TV, and video on demand, which has come from the digitization of TV. And because it's in digital data, we can do things such as fast forward, rewind, duplicate, send, because it's in a digital format. And then 3G technologies, the 3G network being set up for our mobile network services. Okay, so I hope you've got a bit of an idea of what's going on in the communication systems unit. This was all pulled straight from the syllabus, and yes, it's quite a comprehensive and technical unit. Okay, so it's one of the more difficult units in the information processes and technology course. There's a lot of further reading here and a lot of diagrams to look at, specifically the communication systems framework. So good luck in understanding all your different protocols, as well as how these communication systems do all this work, both on our networks and what's going on behind the scenes and what the software is doing.